Hi, this video we're going to introduce the first law that's applied for constant pressure. Then let's start with the first law. Governing equation, we have delta E equal to Q minus W. And if it's stationary, which means delta KE and delta PE is going to be equal to 0, because we know delta KE is equal to kinetic energy change, potential energy change, and delta U. If that equals 0, what we have is delta U is equal to Q minus W, right? And we expand last time the work. There's a boundary work and there's other type of work. And if this is going to be constant pressure, what is the boundary work? Boundary work is going to be equal to pressure V2 minus V1. Okay, so knowing that, we're going to write it again. So delta U, this internal energy change, is Q minus this P V2 plus P V1, then minus work others. Okay, now we're going to introduce a concept called enthalpy H. Enthalpy H is going to be equal to U plus PV. Okay, so if knowing that, we know if it's two different states, so H1 is going to be equal to U1 plus P1 V1, right? But this is a constant pressure, so I'm getting rid of the P1 here because it's the same pressure. Then for state 2, H2 is going to be equal to U2 plus P V2. All right. Now we're going to bring this back to this equation here. Again, we're trying to figure out equation for first law for constant pressure. Delta U is going to be equal to Q. As a matter of fact, I'm going to do this. Delta U is going to be internal energy change, U2 minus U1, and Q minus PV2 plus PV1 minus work others. By using this enthalpy, we're going to remove these things. So U1, and we're going to bring this PV1 to the left. So what do we have here? Okay, so here I made a mistake. This is final U2 minus U1. So U2, bring this PV2 there, so it's going to be plus PV2. Then minus this U1, and then bring this PV1 to the left, we'll have PV1. But instead, I'm going to put a parenthesis, so it's going to be plus. Then what's on the left is our heat transfer and other type of work, others. Now, using this new concept we introduced for enthalpy, this is basically your H2, right? U2 plus PV2. And this U1 plus PV1 is going to be our H1. That's going to be equal to Q minus others. Then what do we have? This heat transfer Q is going to be delta H. This is going to be our delta H plus work others. This is going to be the most essential equation for first law for constant pressure. Heat transfer is going to be equal to delta H, the enthalpy change plus work others. And just be aware, this is for what? Constant pressure process. And do a quick review. What did we have last time? If it's constant volume, we'll have heat transfer instead of delta H. We're going to have delta U, then plus work others. And those are the two most important equations for first law. One is for constant pressure, one is for constant volume. If it's not, if not, constant volume or pressure, what's the equation? It's going to be our most fundamental equation we had at the beginning. Delta U is going to be equal to Q minus W. Just be aware, those two equations coming from this governing equation, delta U equal to Q minus W, right? We start with all there. And then we look at special situation, then we have constant pressure equal to that. Then that's all. If there's no other type of work, so make a note here. If work others is 0, what do we have for constant pressure? Q just equal to delta H. And if there's no other work other is 0, our Q for constant volume just equal to delta U. So that's all. Those are super important. All right, I'll see you next time. Bye.